Alrighty, problem number 6 is also a non-calculated problem. Consider the differential equation dy dx equals 1/3 x times the quantity y minus 2 squared. Right, A slope field for the given differential equation is shown below. Sketch the solution curve that passes through the point 0, 2, and sketch the solution curve that passes through the point 1, 0. So we're going to be doing two things, and basically we're just going to be drawing what we see. So first of all, it says this solution curve passes through the point 0, 2. So here's 0, 2 here. So what do you see happening? What pattern do you see happening? I just see a straight line going all the way across. So you just draw what you see. All right, the solution curve that passes through the point 1, 0, here's the point 1, 0. The pattern that I am seeing is something that looks like this. Okay, please notice that I did extend my solution curve to take up the whole picture, so you want to do that as well. Right, this was worth 2 points. We got 1 point for drawing that horizontal line, and then we got 1 point for drawing the curve that we saw going through 1, 0. Okay, part B, let y equals f of x be the particular solution to the given differential equation with initial condition f of 1 equals 0. Write an equation for the line tangent to the graph of y equals f of x at x equals 1. Use your equation to approximate f of 0.7. All right, so even though they're telling us that this is a particular solution, it is not telling us to find the solution. So do not cross multiply at this step. It is asking us to do two things. It's asking us to write an equation of a tangent line, and it's asking me to use my equation to find f of 0.7. So those are the two things that we're going to do. So if I would like to write an equation for the tangent line, remember we'll have y minus y1 is equal to mx minus x1. We need the slope and we need a point. Please notice that we do have a point right here. The point is 1, 0, so I'm all set for that. We also need the slope. In this case, the slope is the derivative. So the slope is the derivative, which is equal to dy dx. To get that slope, we are going to plug in x equals 1 and y equals 0. So I'll have 1/3 times 0. Oh, excuse me. 1/3 times 1 times the quantity 0 minus 2 squared. All right, so we're going to have 1/3 times 1. 0 minus 2 is -2. -2 squared is 4. So my slope is 4/3. So I'm ready to go ahead and plug it into my equation. So I have y minus 0 equals 4/3 x minus 1. You may write it like that, or you don't like the 0, you can put y equals 4/3 x minus 1, and no need to simplify it anymore from there. So we've done part 1 of the problem. Now it says to use your equation to approximate f of 0.7. So we know from here to approximate that, we're just going to have 4/3 x instead of x, we're going to put 0.7 minus 1. And I'm going to stop right there because I'm not going to chance making a mistake in working it out. If you chose to work it out, you should end up getting an answer of -0.4. All right, we would get 1 point for finding the equation of the tangent line, which would be one of those two, and then we'd get 1 point for our approximation, which would be right there, or the -0.4. Okay, part C says to find the particular solution to the given differential equation with initial condition f of 1 equals 0. Okay, this time it actually does say to find that solution, so we should be blaring in our head right now that we're going to be cross multiplying. So I'm just going to rewrite the equation. So dy dx equals, I'm going to write this more as a fraction so I can cross multiply. So 1/3, the 3 is on the bottom. I'm ready to cross multiply. I'm going to get 3 dy. And if you did that without me and left it as a 1/3, that's totally fine. So here we go from here. So we're going to have 3 dy is equal to, and I can work off to the side if you did that instead, how it would change the problem. X y minus 2 squared dx. I notice that I do not have my y's and x's matched up, so I am going to need to divide by y minus 2 squared. So now I am going to have 3 dy over y minus 2 squared equals x dx. Now I'm ready to take the integral of both sides. On this side, I am going to have to do a u substitution, so u will equal y minus 2. du is going to equal 1 dy. I noticed I have a 3. I only need a 1, so I multiply the inside by 1/3 and the outside by 3. So now this is a 3 on the inside. Now I have u to the -2 du. And now if I were to take the antiderivative of that, it's going to be 3 if I add 1 to my power, it's going to be u to the negative 1. The the reciprocal of negative 1 is negative 1, so that is going to end up being negative 3 u to the negative 1, or another way of writing that would be negative 3 over u, which will be negative 3 over y minus 2. Okay, now the other side, the antiderivative of x is just going to be 1/2 x squared. So here I'm going to have 1/2 x squared, and then don't forget at this step we need to put the plus c. All right, from here, before I try to solve for y, I am going to go ahead and use my initial condition to find my c. So remember that this just means 1, 0, so x is 1, y is 0. So now I'm going to have negative 3, 0 minus 2 equals 1/2 times 1 squared plus c. So this is going to give me 3/2 is equal to 1/2 plus c. If I subtract 1/2 from both sides, I will get c is equal to 1. So my formula is now negative 3 over y minus 2 is equal to 1/2 x squared plus 1. All right, it did say to actually find the solution for y, so I am 1 point away. So if this next part kind of gets you, please remember it's just worth a point, so don't fret over it. What I am going to do is, so that I can do something with this, I am going to make the right side a fraction, just how the left side is. So I'm actually going to be getting a common denominator. So 1/2 x squared plus 2/2. And so now I can rewrite that as negative 3 over y minus 2 is equal to x squared plus 2 all over 2. And now that I have that, I can either cross multiply, or I did show you the trick that we can just, if we want y on the top, we can just flip both fractions. So I'll have y minus 2 over negative 3 is equal to 2 over x squared plus 2. And now from here, if I want the y by itself, I'm going to have to multiply both sides by negative 3. So now I'm going to have y minus 2 is equal to, please notice when I am multiplying by negative 3 is just negative 3 over 1. So only the numerator is going to get multiplied by the negative 3. So it's going to equal negative 6 over x squared plus 2. And then from here, to get rid of that negative 1, we'll just add 2 to both sides. So we'll get y is equal to negative 6 over x squared plus 2 plus 2. So now I have appropriately solved for y. So my point breakdown on this one is I'm going to get 1 point if I was able to get to the spot where I separated my variables. So right at this spot right here, I am going to get 1 point for getting my left antiderivative. I'm going to get 1 point for getting my right antiderivative. I'm going to get 1 point if I put plus c and found an answer for it. And then I'm going to get 1 point for actually solving for y. So that should give me all the points, and that is problem 6.